Hello class, today we'll learn about the mysterious force known as gravity. As you may know, gravity is one of the four forces, next to the strong force, weak force, and electromagnetism. Out of the four, gravity is the weakest, although like electromagnetism, it can operate over extremely large scales. The strong and weak force can only operate on atomic levels. The person that created the idea of gravity was Isaac Newton. Before him, people like Aristotle thought that heavenly bodies move towards their natural place and have crystalline cases all over them in which they would fit into so they wouldn't fall out. Descartes explained things being drawn into the center of the universe by saying that aerial corpuscles would impact loose bodies and direct them into the Earth-centered vortex, which people believed, as convoluted as they may seem. Regardless, Newton was the first to explain gravity by unifying the principle of things falling into the air together with the orbit of large bodies. Ow, what the heck, Apple? Why'd you do that? I don't know, Newton. Why did I do that? Oh my. So anyway, Newton published his law of universal gravitation after some time, and used it to explain Kepler's planet orbit observations. And two astronomers used his equations later on to predict the existence of Neptune. They did it by observing that Uranus was a bit off-kilter, as in, its orbit had occasional perturbations, suggesting that an unknown force was acting upon it. So Newton's law of universal gravitation was pretty useful for the physics community in general, relatively speaking. People liked it because instead of useless guesses about why things are the way they are, he gave them actual equations that can predict gravity's effects with never-before-seen accuracy. His universal gravity equation is as follows. Force equals the gravitational constant times the mass of object 1 times the mass of object 2 divided by the square of the distance between the two masses. There are more gravity equations than just this one, like the gravity equation for here on Earth and Einstein's field equations, but the universal gravity equation was one of the most useful and important examples of a gravity equation for the progress of science, especially astrophysics. However, there was a problem with Newton's gravity. To clearly understand the conflict, let's say it's a normal Wednesday when all of a sudden the sun blows out. Oh no, you say, before realizing that it is merely a hypothetical example? If Newton had heard about such a catastrophe in advance, he would say that the effects of the sun blowing up would be felt on Earth immediately, and its orbit would instantaneously get perturbed. The problem comes in when we find that special relativity disagrees with his prediction, since in special relativity, information can only travel as fast as light can, and no faster. Due to this conundrum, Einstein would go on to develop a theory that would revolutionize physics, as well as overthrow Newtonian gravity. Einstein had recently published his paper on special relativity, and as we mentioned before, wanted to combine gravity with special relativity. It started with his realization that gravity and acceleration are indistinguishable. If you conduct a series of tests on a rocket accelerating at 9.8 meters per second squared, you would get the same results as if you did the same experiments on Earth. This is called the equivalence principle, and led to Einstein's new and improved version of gravity. In it, he says that gravity is the result of mass bending space and time around it. Imagine a fabric stretched really tight, that's space-time. Now put a bowling ball in the fabric, that's the sun. If you put a bunch of marbles on the edge of the fabric, they will roll towards the bowling ball because the fabric is being stretched downwards. Essentially, that's what happens in real life, but in 3D. Massive bodies like stars and planets stretch the space-time fabric that surrounds them, and smaller masses fall towards them. This is the new basis for gravity that Einstein proposed in 1915, called general relativity. Okay, that's all.